Robertson, and today we're doing Unit 8, Lesson 7, and this lesson deals with algebraic expressions, and we're going to begin with doing some math boxes on page 374. We're not going to do all of the boxes, but we're going to just do part of them, okay? So let's begin with question number 1. Earlier today, we noticed that on our iLearn chart, we were going to have to make some adjustments so that this will work for our iLearn chart. And I'll sneak this up over here for you in just a moment. It says they're making a banner, and Greg measured the distance between the posts as 670.5 centimeters. About how many feet of string are needed from post to post? Well, we just need to go from centimeters to feet. Well, when I looked at our chart, there is no centimeter to feet. But what do we have? We do have meters to feet. So we have to change this to meters. 670.5 centimeters equals how many meters? How many places do we move the decimal point? That's right, we move it 2 places, so it's 6.705. Nice job. Now, it says about, so I can round my answer. I'm going to round the 6 to a 7. I'm going to round it to the 7. About how many feet of string are needed? Well, my number model is going to be 7 times 8 feet. I'm just going to round it to 3. Why? Because it said the word about, and I don't have to use the exact numbers. Now it's going to be a pretty easy number model. 7 times 3 is going to equal our feet. 7 times 3 is 21 feet. Now, if you had 21, some kids had 22 feet, those would be good estimates. Any questions? All right, let's go on to the next problem. All right, kids. In question number 2, when I look at that, it reminds me more of an 8th grade standard problem. But we're going to try to do letter A, and then we'll move on from there. X, Y, Z equals X times Y plus X times Z. Now, here's their example. 8 times 90 plus 2 equals 8 times 90 plus 8 times 2. So now let's do it with this one. This is going to be, that's going to equal 5 times 10 plus 8 is 18. So what does that equal? 5 times 10 plus 5 times 8. 50 plus 40 is 90. Okay? Now, if we did this one, that's the same thing as 25 times 10 plus 3. So that's going to equal 25 times 10 plus 25 times 3. Well, that's 250 plus 75, and you're going to get 325. Any questions on that problem? All right, let's go on to number 3. This is our algebra problem, our 8th grade level problem. So let's look at this one. Oh, I have a B on both sides. How do you get rid of a plus B? Minus B minus B. Draw your line and cancel. What's 3B minus a 1B? 2B plus 11 equals 14. Now, all of you know what to do at this point. How do you get rid of plus 11? Minus 11 minus 11. 2 times B equals 3. Divide by 2, divide by 2. And B equals 1.5. Or you could write it as 1.5. Okay, let's double check. 3 times 1.5 will give you 4.5 plus 11 is 15.5. Is 14 plus 1.5 15.5? Yes, it is. Let's go to question number 4. In question number 4, who can go up there and show me where is negative 3.5 up on the board? Go on up there for me. And well, am I going to put an open or a closed circle? It's got a bar. It's going to be a closed circle. So everyone put a closed circle. Now, y, your variable, has the little point. Where do the little numbers live? To the left or to the right? To the left. Very good. There we go. So that one, everyone can get that one right. We're not going to do number 5 because that's not one of our standards where we're finding surface area. So we're going to skip number 5, but we're going to do number 6. It says use substitution to determine whether the number makes the inequality true or false. Now, if you replace x with 3, that's not 53, it's 5 times 3. What's 5 times 3? Is 15 greater than a 27? No, that is false. Now in this one, we're going to replace g with a 2. It's not 72, it's 7 times 2. What's 7 times 2? Okay, and 14 plus 13 is 27. Is that greater than a 26? Yes. True. Very nice job, kids. Now we're going to turn back. We're going to go backwards. We're going to do our math journal, page 373. Page 373. I like how most of you are making good choices. Now, we're going to look at this picture thing that they have down here, and we're going to write step 1. You got a block and 3 empty blocks. You got a shaded block and 2 rows of 3 empty blocks, and so on. Okay, what do they want you to do? It says, plan your numeric expressions to show one part of the expression as a constant and another part as varying. Well, in all of them, they have 1 block shaded, right? So for this one, it's 1 plus 3 times 1. You have 3 in the row and only 1 row. So that's why they have it. Put your little parentheses around there. It just makes it a little easier. On this one, you have 1 plus, how many are in each row? 3. How many rows? 3 times 2. So are there 7 blocks? Yep. 1 shaded. Now let's do the next one. For step 3, it's 1 plus
3 times 3.
Very good. We have 3 rows of 3. On the next one, 1 plus
3 times 4.
Very good, Grace. And that's how we're writing these, okay? Now, let's just add another row here. This is actually going to be the answer for problem number 3. N. If we have n rows, what's our equation if we have n rows? 1 plus 3 times n, okay? Or you could write it as 1 plus 3n. The variable n can represent any situation, okay? Does everyone have that? Now we have to do the part where we're going to describe this, okay? So let's write our description. Number 2. Describe what is constant and what varies. Well, the shaded square is a constant. Every one of them has 1 shaded square. The word constant means it doesn't change, and there's always one shaded square in each row. There's another constant. How many are in each row? There are 3 boxes in each row. There are 3 boxes in each unshaded row. Because the first one, there's just 1 box in the top row. In each unshaded row. That's also a constant. So these 2 things are constants. What varies? The number of rows varies in each. The number of rows if you want to. All right. I should spell V-A-R-I-E-S, varies. Okay. Any questions? And you all know what's the answer to number 3. We already wrote it up there. The answer to number 3, write an algebraic expression for the number of squares in step n. Well, we already did that right up there, so just write that down here. 1 plus 3n. Okay? Now, as you finish that up, I'm going to pass out our worksheet. And then later on, you can turn your math journals in. We're done with our math journals now. Okay, now we all have our Math Masters 8-7. And before we do any of these problems, we have to shade something. We have to come up with a pattern. And let's just all do the same pattern where we shade the top 4. Top 4. Now that we have these all shaded, we're going to write expressions for each one of these problems. All right? So go ahead, look at it, and see if you can come up with an expression. All right. In problem number 1, I have 4 shaded. So it's 4 plus, how many are in a row? 3, but we don't have any empty rows, so it's 3 times 0 is 0. So we just have 4 for that one. So now for the next one, how many do I have? 4. How many are in the row? 3. How many rows do I have in step 2 that are not shaded? 1. So it's 4 plus 3 times 1. Now, in step 3, I have 4 plus, there are 3 in a row. How many rows do we have that are not shaded? 2. And yep, well, that'll give you 10, and we've got 10 of them there. In step 4, we have the 4 that are shaded, plus how many rows are not shaded?
3.
And 9 plus 4 is 13. Yep, that's how many we have. What is our constant and what varies? Okay, our constant in each one of them, how many are shaded in each one? 4 boxes shaded. That's a constant. And the other constant, how many are in each row? 3 boxes in each unshaded row. That's a constant. 3 boxes in each unshaded row. Now, some of you aren't writing this down, and I know you don't have it written down, so please write this down and save this paper because it can help you. You can use this on your test next week. Now, what are some of the things that varies? What varies? How many rows? That's right. What varies? The number of rows. In each one, we have different numbers of rows. Nice job. Now it says, write an algebraic expression for the number of squares in step n. So here, let's go up here. Let's just add another little box like we did. I think so. If it's an n, we have 4 plus 3 times n, right? So if we have this expression, 4 plus 3 times n. Okay? We're not going to do number. Well, I guess we could do number 4. Explain how you might convince someone that the algebraic expression you wrote in problem 3 is equivalent to the expression you wrote in the math message. Well, in this one, you count one row in what was shaded in problem 1. In problem 1, not part. Problem 1, that's a number 1. So one row of 3 is already built into the constant. Built into the constant. All right, now we're going to go to the back side, and we're not going to do the last two, 8 and 9, on the back side. So turn it around, put it at, we're not going to do 8 and we're not going to do 9 on this paper. We're going to do this problem here. It says create your own growing pattern for one of the initials in your first or last name. Kids, we're going to just do it to the letter K. And then you can do another one of your initials later on if you want to. So I'm going to show you what they want us to do. Step 1, I'm going to draw a box K. So I'm going to have 3 boxes on the left side, a box in the middle, and then I have a box here and a box here. Okay, that's my K. And I'm going to shade them. 1, 2, 3. It'll look like a K when I make it bigger.
Oh, okay.
It evolves into a K. Okay? Now, for step 1, how many do I have shaded? 6. But I'm going to do something else. I'm going to add 1 to each end. I'm going to add 1 to this end. I'm going to add 1 to that end. I'm going to add 1 there and add 1 there. So my equation is going to be 6 plus 4 times 1. I just added 1 to each one, but I had 4 of them. Now we're going to do step number 2. In step number 2, again, we make our shaded K. Now you got to bring it down a little bit because we're going to add 2 blocks on each thing on this one. Okay. I don't know why I'm having problems. It doesn't want to touch there. All right. Now instead of adding 1 to each spot, I'm going to add 2 blocks. 1, 2, 1, 2, and I feel like we're doing Transformers almost. It's like they're coming to life with their long arms. 1, 2. Does everybody get there? See, it's looking more like a K all the time, isn't it? So, oh, I forgot to shade my first 6. So what does this one have? It has 6, that's our constant, plus 4 times 2. I added 2 to each spot. Now in step 3, how many do you think I'm going to add to each one? 3. Yep, let's draw the K. And then we're going to shade it. Shade them. Now we're going to add 3 to each one. 3 on the top. 3 on the bottom. Again, I feel like it's coming to life. 3 on the side. 3 going down. It's getting bigger, isn't it? Step 4. So, this one is 6 plus 4 times 3. Now, our last one is going to be our giant K. Now we are going to add 3 to each end. Or no, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Whew, we got that one all done, didn't we? And that one's going to be 6 plus 4 times 4. Okay, now it says write an algebraic expression for the number of equations in step n. So if we added an n, it would be 6 plus 4 times n, wouldn't it? 6 plus 4 times n. Then it says, describe how the parts of your algebraic expression represent the constant part of the pattern and the part that varies. What are the constants? Well, each one has 6 shaded squares. And 4 spots that we add squares. And 4 spots where there's an H in there, where squares are added. What varies the number of squares added? Varies the number of squares added. Okay, now we have this one finished, and then it does ask what I thought we would do, and we're going to do reflex for the end of the class. But if you wanted to get a half a sheet of paper, the other class did this, and let me show you what they made. Some of the kids liked doing this because they were finished with their reflex. So what they did is they found a letter, and you have to make 4 of them. They started with an L, then they added 1 to each one, added 2, added 3. There's an L. Here's Rachel did an L. This one did a Z. Their Z, I think that needs a little work on it. Here, they did an I, but the I sort of looks like it turns into an H, which is fine. I like the U. Somebody did the U. A lot of kids did the L. Oh, this is an L in a different way. This person did a different type of thing. So if you are done, if you can't do reflex, you can do one of these, get a half a sheet of paper and create your own letter and pattern with it. So have a good day.